Hey guys, and welcome back to a new video for the scripting tutorial series. In today's video I will be covering some special data types. These are very useful and are often found in most scripts, but they are quite harder to learn than strings and booleans. So for today's video I will be covering the following data types: color 3, BrickColor, vector 3, CFrame, Udem2, instance, and Enum. Regarding vector 3, I will be also covering some basic arithmetic and something called magnitude. So all that being said, let's just start with the video. To cover the first data type, which would be color 3, we will actually need to add a part in the workspace. So this data type can be used both in parts and also in GUI objects such as frames, buttons, text, among others. This data type is present in this color property, which is made up of an RGB value. RGB stands for red, green, and blue, and each of these values ranges from 0 to 255. So for example, if we only gave red a value of 255, which will be the maximum, and all the others a 0, the part would be fully red. Alright? So this is pretty much how RGB works. You can also use this select color panel, which pops up whenever you click on this little square. And for now we will just use this red color, and through scripting we will change this red color to a blue one. So I will add here a normal script inside the part, okay, and I will wait 5 seconds and then change the part's color to blue. So script.parent.color, right, we are referencing the part inside the workspace, and then changing its property called color, and here we will actually set it to color3 dot from RGB. Now as you can see here, there are lots of options, but the main ones are new and from RGB. I will cover the new one later on. For now we will use from RGB. Now this one will take 3 numbers, which will be the ones used for the RGB value. So the blue color would be 0, 0, and 255, since we are giving a maximum value only for the blue. Alright, so now here we will just give it the numbers, right? 0, 0, and 255. Now if we run this, you will see how the part's color will actually change. Right, from red it will go to blue. See? So now the other thing you can actually use is .new, alright, which is pretty much the same thing, but now each value, instead of ranging from 0 to 255, it will range from 0 to 1. So if we wanted to make a blue color, we will just type 0, 0, and 1, and this one will do the exact same thing. See? So that will be pretty much the color 3 value. It can be used the same way for GUI objects. So now the other data type is BrickColor. So I will erase everything in this script, and well, BrickColor is pretty much the property, this property right here. It's the first one that shows up, and it pretty much is another way to change a part's color, but it's kind of like the colors Roblox lets you choose quite easily. So if you don't know how to use RGB, you can just do this. So for example, this color, bright green, has its own RGB value, but so if we wanted to do the same thing as before, let's just give it this really red color, which is 25500, and we imagine we wanted to change, for example, to really blue, okay, but we won't be using RGB values, we will just use BrickColor. So now to do this, what we will do is, as before, wait 5 seconds, and here we will reference script.parent.BrickColor, right, to change the BrickColor property, and now we will create this BrickColor data type by doing BrickColor.new, and here in between parentheses we will type the name of the color we want to set. So in my case, really good. Okay, now there are, as you can probably see, there are lots of different colors, such as really black, there is as well, bright blue, dark blue, etc. Anyways, if we run this, you will see how the same exact thing will happen. Alright, so that's pretty much color 3 and BrickColor data types. They are quite common, and well, they pretty much do the same thing, but just in a different way. Alright, so next up we have the vector3 data type, and this one is a little bit harder to understand, but I am sure you will get it right. So I will also add a part, okay, and this vector3 value is present in two properties mostly, maybe in another one, but mostly it's present in the size and the position. Now we will be working with the size for now. So a vector3 value is composed of three numeric values called x, y, and z. Each of these values corresponds to a specific dimension. This vector3 value is 3D, that's why it has 3 dimensions, and for example, if you just gave it a 1 in each dimension, this part would be a square, right? Or a cube. For example, on the other hand, if you gave it, for example, 10 in the z dimension, in the z dimension, you can see how now the part is way more larger and more wide. It's way more wide. Okay, so this is pretty much just how vector3s work. So now I will actually tell you how to do scripts with them. So if you, for example, we just wanted to change the size of the part or the position, for example, I will wait 5 seconds and then do script.parent.position equal to a vector3.new, and now okay, I will just make this part a square, and for now I will place it in the position 0, 5, 0. Okay, so this corresponds to the center of the base plate, as you can see, but a little bit more upwards. So imagine I wanted to move this part from 0, 5, 0 to minus 5, 5, 0. So in order to do this, I will just set the position to a vector3 value, which will be minus 5, 5, 0. Now if you run this, you will see how after 5 seconds the part will move. Okay, I will actually enter the part, and well, this is pretty much just how vector3s work. And now I will tell you about basic arithmetic. So I will create first of all one vector, which will be, for example, 5, 5, and 5, and I will create another vector which will be 10, 10, and 10, for example. Now you can actually do some basic arithmetic with them, such as adding them up together, subtracting, multiplying, and dividing. Now I will create a variable. Well, I will create 4 different variables, one for each operation. Now the sum would be just vector1 plus vector2. The subtract would be v1 minus v2. Multiply would be v1 times v2, and finally divide equal to v1 divided by v2. Alright, now let's just print each of these and we will see what happens. Okay, I'll just play, and in the output you can see how when adding them up together, it is pretty much adding the x value of well, the x dimension of the first vector plus the x dimension of the second vector, and it did that with each of the with each dimension, and it pretty much works the same way in all of the operations, as you can see here. Okay, so now I will tell you about the magnitude property. well, I'm not sure if it's actually a property, but you can actually see a vector 3's magnitude. So now in this script, just having one vector 3, you can actually print v1.magnitude to access a vector 3's magnitude. You could also do it through here, but for now we will use it this way. So if we run this script, we'll print 8.66. So where does this number come from? So if we place this part in 555, which will be actually this where this vector 3 is located, I will actually create another part which will be in the center and place it on the 0, 0, 0. Now I will delete the script from this center part. Oops, alright. And magnitude essentially gives you the distance between the 0, 0, 0 and the vector 3 you told it. So now this part is in the vector 3 555. So if we just made a part which goes from this first part to the center, we will see how the size of the part will actually be 8.66 or almost that. We can't really do it exactly that number, but we can actually get quite close to it. So now, for example, this part is kind of going from, well, actually I will rotate a little bit more. Okay, I think that should be a little bit better. Make it a little bit smaller. Right, now if we will go here, we can see how this value is actually, the size of it is 8.7, which if we compare it to the 8.6 we had before, it's actually pretty close. So now oftentimes what magnitude is used for is actually to calculate the distance between two parts. So for example, if I made this part 2, okay, I will actually place it, for example, here. If we wanted to calculate the distance between these two parts, we would pretty much just get, first of all, v1 would be script.parent.position, v2 would be script.parent.part2 position. Okay, and now what we would pretty much do is subtract one vector 3 from the other. So result will be v minus v2, and now the magnitude would pretty much be a result dot magnitude. Okay, if we run this, we will get that these two parts are 12 steps away, or 12.8. Okay, so that will be everything regarding vector 3s. Alright, next up we have CFrames. Now these are quite harder to explain and to understand, but I will try to do my best. So we will also add a part here. I will make the size of, well, I will color it red and make the size of it be 111. Okay, I will also anchor it, and I will actually, CFrames are pretty much present also in the position of it. So here you have CFrame, and this CFrame has the position and the orientation. I will position this part on the 050 as before, and we will be playing a little bit with the orientation of this part. So I will actually add a surface gray to actually know where the part is actually looking at. Make sure this surface gray, the face of it is in the front, and now you can see how the front of the part is looking, is this face right here. So now that we have this, I will actually add a script inside of the part, and wait 5 seconds as always, and just do script.parent.cframe. Now you can do multiple things here. So for example, you can use .new, which will just return a blank identity, as this this says, it will be pretty much 0, 0, 0. You can also give it a vector 3, which will pretty much just change the position of it to the vector 3 you told it to, but the part will actually have no orientation at all. You could also, this is quite interesting, give it a vector 3 as well as another vector 3, and the part will actually look at that one. So I will actually try to do this. So the first, we don't want to move the part. We don't want to move the part. So the first argument will be just the part's position, and the second one, for example, imagine we have another part located, I don't know, here, for example. Okay, I will color it blue. And now imagine we wanted this red part to look at the blue part. I will call this goal, for example, the script of it. Okay, and now here the second argument will be the goal position. If we now run this, you will see how this red part after 5 seconds will look at this blue part. See, now you can see how this part is essentially just looking at the blue part. So this is quite useful when, for example, if you're building some type of tower defense game and I don't know, some of the soldiers have to look somewhere specifically, you can actually use this. Or also, for example, when using the camera. So for example, when using the camera, this can also be used a lot. Okay, so that will be pretty much the basics of the CFrame. Now you could do also something more interesting, but that's probably for another video, where you can, well, of course, you can just create change the position. This will be like giving it a vector 3, but for example, this is quite harder, where you are giving a quaternion and here of a new orientation, but that's really hard to actually explain and to understand, honestly. So I will just delete this part, and that will be everything regarding the CFrame. Alright, so next data type is UDIM2. This data type is often used in UI objects such as frames, buttons, text, etc. And for example, I will add this screen UI here and a frame in it. Now this UDIM2 is pretty much like the vector 3 for parts, but this will be a kind of like a vector 2 for these types of objects. Now if I select the frame, the size of it, this is an UDIM2 which has an X and a Y, and each of these have a scale and offset. Scale is relative to the screen's size, so for example, setting the size to 1010 will set both scales to 1 and both offsets to 0, and this will occupy the whole screen. Instead, if using just offset, it doesn't matter how big your screen actually is, then the size will remain the same size in pixels. So now this size position is UDIM2 and position is the same thing. To actually script it, I will add this script here, and imagine I wanted it to double in size. Right now the size of this frame is 050 050. So here I will wait 5 seconds and script.parent size in our case will be equal to UDIM2.new, and here we will just pass in 4 values. In our case will be 0, 100, 100. So this will just do, so we'll just do it so the frame actually doubles in size as I said before. See? Okay, so that will be pretty much UDIM2. It's quite similar to vector 3, and I believe it's easier to understand. Alright, so the next data type is actually probably the most common used one of all, and this is pretty much an instance. So I will add a part here, and so I'm data script inside it. So now the instance data type, pretty much what we'll do is when referencing, for example, an instance, right? We just do script.parent. If we wanted to reference the part, this part, if we wanted to reference the baseplate, we would just do script.parent.parent.baseplate, right? Now we can actually store this instance in a variable. So for example, baseplate is going to be equal to this. If we now print this baseplate, you can see how the output will just print baseplate, and if we click on it, the baseplate will be selected. So this is pretty much just storing this instance. You can do, for example, you can do multiple things with this, such as destroying it. You can just destroy this instance doing baseplate column destroy, which will just, as you can see now, well, it destroyed the baseplate when we run the script. You can also clone it, but all of these methods we will be covering in another video. But pretty much an instance allows you to store, well, an instance in a variable. We can also, for example, as we did before, change the BrickColor of it to, for example, really red. And now if I run this, you will see how the baseplate changed its color to a red color. So this will be pretty much everything for the instance data type. It's quite straightforward as well. Alright, so now finally the last data type is gonna be the Enum. So I will keep this part here, but erase all of this. So now Enum. Pretty much Enum, there are a lot. For example, in out, using style, using direction, using camera type. There's a lot of them. But I believe like the easiest one you can use is probably the material one. So if you just go to this part, see this material right here is an Enum. Okay, it has multiple options, such as, for example, crack the lava. Okay, and pretty much it's just the material of the part. Okay, so now I will set it to its default. And now what I will do is wait 5 seconds and change the material of this part. So script.parent.material is going to be equal to an Enum data type, and here we just type enum.material. Now we can access all of the materials there you can find. So if you just wanted it to be, for example, limestone, for example, if we now run this script, you will see how after 5 seconds this part's material will change. See, it changed. So pretty much this will be Enum. You can actually use this, for example, when using twins, which I will teach in another video as well. You can, for example, use the using style, linear, bounce, or erasing direction, in, out, etc. But eventually this will be everything. So anyways, the video is over. I know I haven't really been uploading much, but mostly it was because I was really busy, and hopefully now during this summer I can actually upload way more videos. So well, thank you all for watching. I know this video was quite long, so I might have divided it into 2 parts, but anyways, thank you all for watching. Consider subscribing if you want me to post more videos, and well, bye.